Hi, I'm Bob Vila. Welcome home again to our Vermont farmhouse project. Today we're building some dry-laid stone walls up in the front of the house. It's really a retaining wall and it's built out of Corinthian granite. We're also going to be taking a tour of some of the Vermont covered bridges, beautiful 19th century nostalgic features. And we're building a staircase in the front hall. Stick around, it's good to have you home again. All right, let's get started today with a little bit of landscape, hardscape construction. You can see the conditions here. We're building on a hillside. And let's say hi to Hector Santos, who's building a retaining wall for us.
Pleased to meet you.
Hi, Hector. Is this the kind of soil condition that you encounter all over the place up here?
We have varying soil conditions. Some of it's mixed bag of gravel and large stones.
But here, there's a lot of clay in this.
Yeah, this is clay, and it doesn't make for the best wall building conditions. So I
would think that it's so sticky that you wouldn't really need a retaining wall, but I guess you can't really plant on this.
No, it doesn't make very good planting.
So what have you put down on the base already?
What we have here is about 1 foot to 8 inches of 3/4 inch ledge stone.
And that is kind of the base for the stone wall that you're building along here.
Exactly.
Hector, what kind of stone is this? It's got this very nice kind of purplish green tinge going for it.
What we have here is a stone from Champlain Stone. They're located in upstate New York.
But is it granite?
It is a granite. It is their Corinthian granite. It's comprised of 70% Hudson River blue, and as you can see, it has layers of really beautiful colors. We have some purples and greens and
beautiful
reds.
Burgundy colors and greens. Look at the greens on this side, right? So they all kind of come in more or less a squarish configuration.
Yeah, it makes a nice random coarse pattern, which is what I'm working on now.
Excellent. Now, how do you lay out a wall like this?
Well,
how do you figure out the construction of it?
A rule of thumb that I like to use is I like to make the base of the wall as wide as it is high. So, for instance, this wall is going to be 3 foot high, so what I like to do is have a 3 foot or even a little bit wider wall at the base, and as you can see, it slightly tapers up in the back. And
so that by the time you finish up here, all we'll really see is this much.
Yes.
And the soil will come right back up to here, including the sod.
Exactly.
Gotcha. And then why is it angled on the front?
Well, what I do with that is, as you can see, some of these stones also pitch back. The theory behind that is if you angle a wall back, when the ground heaves, it'll push it forward, and then it'll settle back, where if you made it plumb and it heaved forward in time, it would just eventually creep and fall over.
Creep and fall over.
Yes.
We don't want that to happen. It looks so beautiful, and it's such a hard thing to select the stones as you're going along to get them to look like that. Now, Hector, what are you going to put there next?
Well, I have this piece here which has a really nice face, and it will hopefully just fit right into place.
So that the main consideration at this point is the face that you're going to be looking at.
Yes.
And you don't worry about how it's going to fit in behind the face, that void back here?
What I will do is I will find a piece that will fit into here and tie back into these stones in the back.
Okay.
So this one, what I'll do is I'll lay it up first, and because this is a curved wall, I don't have any place to put strings.
Yes.
So a lot of this is all done by eye. So what I'll do is I'll basically stand down the face of the wall and I'll look to make sure that it runs in line with the rest of the stones.
Right.
Now, it isn't going to be exactly perfect, but neither is stone. So if there's a little bit of variation, it's going to be okay.
Sure.
So the next stone that I'll choose will go to this height, because if it sits up higher, what you don't want to do is you don't want to run your courses so that they're stacking on top of each other. So in order to accommodate for the next stone, I've chosen this one, which will probably fit right into here.
Which will even up the level between this one and this one.
So your next stone will run right over to the next one.
Okay.
Right over to here.
Again, you want that
face
to...
And another thing you need to keep in mind is that the stones shouldn't wobble. You set a stone, you stick shims underneath if it does wobble. By the end of the day, you should theoretically be able to walk right down the stones that you've laid and not have them wobble underneath your feet. So the next stone will fit right on top of here, And let's see if we could find one for that spot.
How about that one you're just stepping on?
Okay. Actually, I think this one might make a nice cap. When you're doing caps, you want to have them be as flat as they possibly can be. So that way, when you stand back and look at your wall, they're running in an even line and they aren't running in a wavy pattern.
Yeah, one even line, and of course the sod will come right up to this edge.
Yes, it will. And another important thing when building a wall is you'll find stones that will have what look like a nice face. This stone here has a beautiful face, and why not use it in the front? I'll tell you why. Because what will happen is a stone like this will probably fall over. What you'd rather do with a stone of this type is turn it this way so it ties back into the wall.
In any dry laid wall like this, you're going to really depend on shims to keep things tight, right?
Yes, you are. One of the things with shimming is not every stone is perfect.
Right, they're not all perfectly flat. Now, you can't use your string as a guide for the face of this wall because it's curved, but you are using a string as a guide for what, for the top?
Yes, what I'm doing is I'm using the string as a guide to keep the tops all in one even plane. So when you stand back and look at it, they're all nice and even. And what I did is I went around and I marked various spots around the stone wall with my transit. And what I'm doing is I'm leveling from here to here and running a string from this point to a finish point.
So you can keep transferring over to the line as you stack them up.
Yes, I do.
Great. Well, Hector, we'll let you keep on working on this and check back with you a bit later in the show. Thanks. Coming up next, we'll take an architectural tour of some of Vermont's historic covered bridges. The ubiquitous covered bridge. Behind me, we're looking at the Middle Bridge here in the heart of Woodstock, Vermont. They're one of the most nostalgic features of the state of Vermont, and in their heyday, there were many, many of them all over the state and all over New England. They were very popular between about 1820 and the early 1900s. Of course, the main reason that they were built out of wood is that wood was so plentiful. There was no steel in that era, and around here you could fell trees, hemlocks and spruce that were probably close to 100 feet long. So the bottom chords and the top chords of the bridges are made out of these original timbers. Now, Timothy Palmer, one of the early 1800s bridge builders, decided that it would be a good idea to put a roof over these bridges to protect these timbers, and that's the origin of this type of a bridge. This example here is a town lattice bridge, and that refers to the actual supporting system. A fellow named Ethel Town designed this particular type of support, and it basically is like a trellis that runs across the whole width of it, and it is going from the top chord to the bottom chord so that the members that are at an angle heading back towards the banks are in tension. Now, the interesting thing about Mr. Town was that he never really built a bridge, but he patented this particular design so that anyone who wanted to build a bridge like this had to pay him $1 a foot royalty. He's one of the pioneers of licensing. Woodstock's Middle Bridge is actually a perfect reproduction of the town lattice style, but it only dates to 1969. And of course, it's a great tourist attraction. Here you can see what we're talking about. The planks that you're looking at forming these X's are the trellis, and they go from a double row of cords on the top to a double row of cords on the bottom. If you're looking at the members that go towards the riverbank, they're the ones that are in tension. The others are in compression. But the real fine point is the way everything is attached with these trunnels that go through the whole 6 or 8 inches of wood here to keep them from moving either way. And of course, then you've got the beams themselves that go across the span here to carry the roadbed. The town lattice truss seems to be one of the favorite methods of bridge building in this county. You can see the town lattice truss over in Heartland at the Martinsville Bridge from 1881, in Springfield's Baltimore Bridge from 1870, and the Downers Bridge, 1840, in Wethersfield. And it was also used not far from here in the longest wooden bridge in the United States, the longest two-span in the world, stretching 465 feet across the Connecticut River between Vermont and New Hampshire, the Windsor-Cornish Bridge from 1866. It's so popular, they're even building a new bridge using this system over in Heartland. The next most popular methods of bridge construction would involve either the king post or the queen post structure. And here at the Taftsville Bridge, you've got an unusual mongrel, practically, a combination of both of those. You see the king post over here where the diagonals meet it, and then in other areas where you have a horizontal timber across, that makes it a queen post. This bridge also has these laminated arches that were added after it was built. This one dates to 1836, so it's the fourth oldest covered bridge in Vermont. The Lincoln Bridge is the last remaining example of the Pratt arch. This particular type of truss, invented by a man named Pratt back in the mid-19th century, relies on a laminated arch that spans the whole river and has wooden vertical members and crossed iron rods carrying the lower chord that the roadbed is built on. If it looks somewhat familiar and modern, it's because this is the design that has inspired countless iron bridges all over the country. Well, whatever their style of construction might be, the covered bridges of Vermont have gained their special significance because of their grace, their beauty, their roots in Yankee practicality. It's nice to see that the remaining ones are being lovingly preserved. Next, we'll build a staircase in the front hall at our Vermont farmhouse. Stick around. Staircase construction in an old Vermont farm-style house should look pretty traditional, but that doesn't mean you have to build it in an old-fashioned 19th century way. What we're looking at here are 4 stringers, usually cut out of spruce, and the stringers are really the backbone of the staircase. They're going to be holding the treads and the risers and obviously the weight of everybody that's going up and down the stairs. Now, our staircase builder, Mark Fortunati, has already taken care of cutting and roughing in the staircase, and all the other trades have come through the house. Now he's back in the house in order to put the finishing touches in. And what he already has accomplished is cutting and fitting the skirt boards. The skirt boards go basically as a continuation of the baseboard along the floor up the side of the stairs all the way to the top. And these have to be carefully fitted and cut, and that includes putting in a dado on the back of each rise and on the back of each riser so that the two are fitted together as in a traditional joint. Now over here you'll notice that he's already put in place one of the turned newel posts which come direct from the factory. Now show me exactly how these fit together, Mark.
Well, this riser fits right into the skirt like this, just like that. And
that's the back side of the works, but if you were walking up the stairs, you'd start seeing that fit like that.
Yeah, just like that.
Okay, shall we glue them up?
Yeah, I say we just glue them up. Just like this. Right in the back so the glue doesn't make a mess. And, just like that. Just kind of get it on there. All right.
All right, so we'll put them all in place for you. Is that the right orientation?
Yep.
Okay.
And then we got that last one that goes right up there.
Okay.
Okay.
So nailing from the back assures that we're not going to see any kind of nail heads. All right, now we can push it back into place. Will it fit there?
Yeah.
Excellent. All right, now we're shooting 2.5-inch nails right into the face of the first riser. And are you ready to try to fit the first tread?
Yeah. We'll see how this dry fit a little bit before we glue it. Okay. Looks like, oh yeah, that looks like it's gonna go in nice. It's fit perfect right there.
Fits fine on the corner.
Yep.
All right, so how about some panel adhesive?
Sure. This will prevent some serious squeaking.
Yeah, that's one of the keys in terms of good products that are available now. A good adhesive like this will not only help it stay together, but it'll prevent any noise in the future.
That's a nice fit.
Excellent. This is the outside skirt, which is cut a little bit simpler. There's no rabbiting, but we do have a miter cut on each of the risers so that when it fits in, you should have a tight fit just like that. Now, all the pieces of the staircase are carefully fitted, but many of them do not get glued together. All the balusters are just really in the little holes that receive them. But here, where the handrail will go right on top of the newel post, you do want to put a little bit of adhesive. And Mark, you ready with that? Sure. Bring it on up. He, of course, has dry fitted this once. And then once he sets it down there, the spindles or balusters go into the bottom of the railing one by one. And it's important not to have them glued or nailed because you want them to float and move if they need to with expansion and contraction. It's going to be a beautiful staircase though. And as you can see, all the rest of the treads and the risers are already in place. How's that? And then this one is just scribed into place, so that one will need a fastener, right?
Yeah.
And then up here, we have another transition that he'll get to. There you go. I'll put the glue in for you.
Thank you.
And one neat thing to look at, this isn't on yet, these little jigs are supports that are temporary here, which are very important when you're trying to work on one of these all by yourself. And he's done a great job. When we come back, we'll check on the progress of our stone wall. Don't go away. Now, some of these pieces of granite that Hector's using on the base of the wall are really quite large and heavy, and some of them are too big to lift, right? You've got to cut them in half?
Yes, in order to make them a little bit more manageable, what I'm doing is I'm drilling holes, and what I'll do in this particular stone is to drill a series of 4 holes about 2.5 to 3 inches deep, and I'll take these what are called feathers and wedges, and I'll stick them in the hole and line them up in the direction I want the split to occur. So I'll put this one here, drill
make
a
another
hole.
drill with the hammer drill, yeah.
Yeah.
Now we set that in, and all we have to do is hit it with a striking hammer, right?
Yeah, in a series of consecutive blows. So you want to hit each stone the same amount of times, so that way it will apply even pressure on the stone as it goes. Kind of like tightening the lug nuts on a car. And then you'll hear it start to crack and pop. There it goes. And that's all there is to that.
And now we just have to lift it up with your little tractor.
Yeah, and set it right into place.
Okay. Okay, and one step closer to finishing up our wall. We're running out of time. Come home again next week. We'll be installing garage doors and taking a look at a vernacular Vermont farmhouse. Till then, I'm Bob Vila. It's good to have you home again. For lots of information and resources for your home improvement project, check out my website at bobvila.com.